Hi everyone, you're welcome to the Trillionaire Math. In today's video, our goal is to solve the following integral problem. Let's get right into it. The first question here says integrate 1 over x minus 1 dx. Okay. The technique to solve this problem, a 1 over x minus 1 kind of problem like this, is to make what we call a u substitution. And by that I mean I will say let u equal x minus 1. Okay, so I'll do a change of variable, I've done a change of variable which is u equals to 1 minus x minus 1. Now differentiate u with respect to what? X, and we'll have differentiate x here, we'll have 1, differentiate minus 1, that's 0. And this also implies that the x is equals to what? The u. Now, let's substitute u into this position. We'll have 1 over u. Do we write the x? No. Now that our variable is u, it has to be du. So we'll substitute u, we'll substitute x, and which is x is now du. Now recall we solved in this class that when I take that lane, when I differentiate lane x, just say lane x, okay, prime, lane x prime is equal to 1 over x. Okay, now what do I need to do? If I want to undo this prime, lane x prime, if I take integral of this, I would have lane x is equals to integral of 1 over, if I take integral of both sides, I'll have lane x is equals to 1 over, is equal to the integral of 1 over x. We'll apply that rule here. Okay, so when I integrate 1 over x, I'll get lane x. When I integrate 1 over u, it's equal to what? Lane u. So we'll have it's equal to lane u. And what do we do next? What do we do? I introduce a k. We introduce a constant of integration. Mind you, this u wasn't given. It's just, we're not done yet. We'll make what? We'll substitute back x minus 1 for u. So we'll say lane x minus 1, okay, plus a constant of integration. Mind you, we'll have to put this what in absolute value, because the negative of that of a logarithm expression, it's undefined. So we'll put that in absolute value. This value can't take to just say that this value has to be positive, okay, or non-negative. All right, that's that. Let's take the second one, number 2. Check. Number 2, integrate 1 over x minus 1 dx from 2 to 3. Okay. Integrate the lower limit of integration is 2, the upper limit of integration is 3. It's the same question, but just some little difference. So now what do? We do the same. We make the same u substitution. Let u be equals to x minus 1. Okay. Now differentiate u du with respect to x. So du dx will be equals to what? 1. Differentiate this, you have 1. Differentiate this is 0. And this also implies that the x is equal to what? Du. Okay. Now if I haven't done this, we'll now substitute. Say when x is equals to 3, our u will be substitute x equals to 3 here to get the upper limit of integration for u. Okay, so when x is equals to 3, u will be equals to what? 3 minus 1, that's 2. When x is equals to what? 2, our u, substitute 2 here, 2 minus 1, u will be is equals to what? U will be equals to what? 1. Okay, So now say integrate from 1 to 2, 1 over u du. Okay, we'll now substitute what we have here. U is equals to x minus 1, we'll substitute that there, and then we'll put the limits of integration for u. Alright, the next follows is that lane u, integrate this, we have lane u, okay, and our bounds of integration is what? From 2 to 1, or integrate from 1 to 2, sorry. So we'll say lane into bracket 2 minus lane into bracket 1. Okay. Now by law of indices, law of logarithm and indices, when we have log of something minus something, that is equals to lane, this change 2 over what? 1. Okay, and it's also equals to lane 2. This is also equals to lane 2. I mean, or even from here, lane of logarithm of 1 is 0. So we can just leave it as lane 2. So either way, you'll still arrive at the same answer. I hope this helps. Thank you all for watching and staying with me up to this moment. And I'll see you all in the next one. Bye.